Hey guys, what's going on? Paul here. Welcome back to another Cardano video. And this one I'm looking forward to finding out a bit more about, first off, Anastasia Labs and Phil, and then getting into Cardano scaling and what's actually possible. It was a very interesting Twitter space recently. I did mention it in one of my recent videos. We're going to get into that and ZK proofs and what's going to be possible on Cardano. But Phil, very welcome on the channel. Thanks for taking the time to come on.
Of course, yeah, happy to come on.
So, for anyone not familiar with yourself, can you give the introduction to yourself, who you are, and then into, I suppose, Anastasia Labs, which you're a part of too?
Yeah, sure. So I've been in the Cardano space for a while since smart contracts came out, um, and I've been involved in a lot of different projects, dApps that you've probably worked with on Cardano as an independent contractor. And about a year ago, I started my own development firm that quickly scaled up. Now we're at like 11 developers, and we've probably touched almost every major app on mainnet at this point, either with auditing or with architecture or just development work. Um, and yeah, our main focus lately, at least, has been on scaling solutions on Cardano, layer twos, ZK approaches, and just sort of large network impact projects.
Nice. And have you built any of your own projects, or do you still you're contracted out by other projects? Is it?
Yeah, so we do have some in-house projects that we built end to end. A lot of the stuff we built in partnerships, like the dApp store was a partnership project with Maestro, um,
Mhm.
and the Sunday taste test, the Sunday swap taste tests, that was a partnership launch with Sunday, where we, at some point we pitched this idea to a few dexes, and Sunday was the one that bit, and yeah, we did all the smart contract work, and then off chain, and then they collaborated with us to build a nice UI and get it to mainnet, and it's been great since.
Okay, nice. And they actually completed their first official taste test recently with, was it Clarity? Was the
Clarity,
first to
yeah,
go
yeah.
through it. So it's good to see it up and running now. And it's great for projects to have multiple different avenues to launch and get into the market. And from what I've seen of that, a very fair way to launch. So getting into Cardano scaling, there's a lot of talk Cardano can't scale or Cardano is way behind the rest of the market. What's your current thoughts on the market? And then we'll get into kind of options that are there or routes that are there for Cardano.
Sure, yeah. So I like to be transparent about the strengths and weaknesses of Cardano, especially as it currently stands. And when it comes to scaling, that hasn't been our focus for the core development efforts for the past year. And I think that's totally fine. And in fact, it'll the focus that we've taken on chain governance aligns with what I would want and what I think is more desirable than scaling. And a lot of this has to do with like, if you've seen me on Twitter, a lot of the time I complain about the state of the dApp ecosystem, about, the lack of decentralization and true ownership. And the thing I bring up a lot is Uniswap, right? Where like Uniswap, if the whole developer team and anyone associated with the project died, they would go on just fine, right? On Cardano, um, if one developer dies, typically five projects would shit out because we rely so heavily on this small pool of developers. And this is an issue because it's an issue for retail users because it means that when you purchase a token, it doesn't have any actual intrinsic value. It's not like when you buy a token, you have a direct impact on the platform. You basically have to make a proposal somewhere in a form, and then someone has to honor an agreement that they made to, listen to those proposals. And a lot of the time, that gets very messy, especially when the proposal goes against the direct interests of, the company developing something. So, like, if you buy a huge percentage of token A, right, and then you make a proposal on token A's form to do something, say, I want to add this to the platform, or I want to lower the fees or something, and it goes against the interest of the company, then you get in a very sticky situation where, the company has an incentive to just ignore you or do something else or find a reason why they can't do what you proposed. But when you go to Ethereum or large projects of like Uniswap, you just make the proposal, and if it passes, there's nothing the developer team can do. The proposal just goes through and it makes the changes on chain. And I think this is a huge asset so that's for Uniswap, but on the actual L1 platforms, that doesn't exist anywhere else. For instance, Ethereum, right? Even if I own 70% of Ethereum, I can't propose any changes to the protocol. I can't say I want to switch to delegated proof of stake. I can't have any input on the development roadmap of Ethereum. There's no way for me to make a proposal and vote with my Ethereum. You have this long SIP process, and basically the direction of the platform is decided by a small handful of developers. And this is a problem, and it's a problem that we've solved on Cardano with the focus that we've worked on for the past year and a half, right? Instead of going scaling, we've worked with on-chain governance to give real value to the ADA token, in that, you don't have to trust IOG, you don't have to trust anyone. You make a proposal to spend something from the treasury or do something, and that happens, right? And this is the core value of blockchain, a trustless system. But as a result of this, right, because of the focus was on that, and I've just explained why I think it's valuable. We haven't been working as hard on the scaling approaches, but that's changing now, right? Now that the governance stuff is fleshed out, we said, okay, let's revisit scaling and let's make this our priority as an ecosystem. And in fact, what we've seen, because over the past year, while we weren't working on scaling, we were looking at like Solana and other places that have achieved scaling, but they've achieved it without drawbacks, right? Not without drawbacks, because when you look at the trilemma, right, despite what some people say, no one has solved the trilemma. To scale, you have to sacrifice something at some point, right? And the good thing about Cardano is we've already made those sacrifices. We've made those sacrifices in terms of transaction determinism. So we had this concurrency issue at launch, right? And this sorry, my phone is about to die.
Yes.
So we had these concurrency issues at launch, and the trade-off we made for that is we get this deterministic transaction system where you know exactly what is going into and coming out of a transaction. And this is a property that is unique to Cardano. On Solana and Ethereum and other blockchains with non-deterministic transactions, you don't know what's exactly going into and coming out of a transaction. Upper bounds, limits on what's going into them, but when you perform a swap on Uniswap, right, you have no idea whether your transaction will succeed. You'll still have to pay. That's why we have this like whole failed transaction model where they'll pay for transactions that fail and whatnot. And a lot of the time people focus on the failure, right? And they say that's the advantage, that we don't have failed transactions that you pay for. But that's only a small part of the advantage. The big part of the advantage comes with this in relation to zero knowledge scaling. So this is going to get quite technical, but it's just a byproduct of what zero knowledge scaling is.
I'll be here to ask the dumb questions, so it's okay.
So what zero knowledge scaling is, what zero knowledge proofs are in general, is you have a function, you have some computation, and you want to prove that you did this computation, but you don't want to send the whole computation. This is important in blockchain because in blockchain, we have very limited resources on chain, right? And the only way to scale otherwise is you make some trade-off with relation to either, for instance, if you look at the hardware requirements of a Solana validator, right, you'll see they're way, way, way beefier than the Cardano validators. And we could take this approach. We could just say, okay, we're going to bump up all the requirements to run a Cardano node, right? And this would scale the chain. But we don't want to do that because there's a cost to that, right? It means less people will be able to afford to run these nodes, or we'll have to find another way to subsidize the costs of these nodes because it's very expensive to run what is basically supercomputers. So in this approach, zero-knowledge scaling, which you see on ZK EVM and other zero-knowledge chains, is that we send, instead of having the whole smart contract execute on-chain, right? When you do a DeFi transaction, some smart contract runs. Instead of having that happen, you run the whole thing off-chain, which means on your own computer. And in practice, any computer, even your phone probably, has more computing power than the entire Cardano blockchain, because the blockchains are decentralized, so there's some cost to this network communication. But individual devices are very fast, right? So your desktop computer that's sitting in front of you can easily run this DeFi technology on it very quickly, very cheaply, without any cost, because you don't have to pay network fees, right? So you run the swap locally, or whatever DeFi transaction you're making locally, and you build a proof. And you say, okay, this is the computation that I executed on my computer. And instead of sending the whole computation to the network, you just send a proof that your computer ran it and this was the result. And on Ethereum, this is a problem because you don't know the status of the trend. You don't know the inputs that you're trying to prove. So for instance, right, a simple example is I want to prove that I added 5 and 10, right? Then I just add 5 and 10 locally. I build a proof that I added 5 and 10 and the result is 15, and then I send it to the network. And this is possible because we know the inputs. We know that the numbers that we're trying to add are 5 and 10. But on Ethereum, we don't have deterministic transactions in the sense that when someone is building the transactions, right, when someone is making a swap on Uniswap, they don't know where their order is going to come in on the block. So it could be that other people's orders are processed before them, or their order, by the time it's processed, will fall out of a slippage range. And the issue with this is that they don't know the proof they have to send to the network. So on Cardano, everything that you need to build a transaction is fixed at the time when you're trying to build a transaction. You know, these are the exact inputs, these are the exact outputs. So you can make a proof saying, okay, this is my transaction, I'm executing it. And this is the result of the transaction. And you can send it to the network. And this is something that, you know, as a byproduct that we've traded so much to get this determinism, it's something we get for free now. So when you look at Ethereum or other networks that have tried to do ZK scaling, what they need to do is they have these systems called sequencers, which they're introduced and their sole purpose is to reorder transactions deterministically, right? So they have to sort of translate the indeterministic nature of those systems into deterministic systems, which is very hard. And as a result, how they're doing it right now in 99% of cases is it's just centralized. It's just like basically introducing batchers at the protocol level. And their goal is to just reorder the transactions so that everyone knows, so that all the inputs are fixed.
And this is what we see with a lot of layer twos for Ethereum, isn't it? It's, I suppose, the biggest drawback or something that people highlight is how centralized they're very fast, but it's because they have one centralized sequencer.
Yes, exactly. Yeah, and this is a very difficult problem to solve. And in fact, we don't even know if it's solvable, right? Without making large sacrifices. And the great thing about Cardano is we don't have to even think about solving this problem. So, you know, when it comes to zero knowledge research, overcoming this hurdle, right, of how do we tell the user what is the proof they need to send, right? Mm-hmm. That has been the biggest area of research in EVM and basically in blockchain in general for zero knowledge proof scaling solutions. It's how do we overcome that problem? And the great part about Cardano is we don't even have that problem in the first place. So it's infinitely easier to apply zero knowledge scaling solutions to Cardano, where we don't even have to think about solving that problem. Users just know, because the protocol, the L1 protocol guarantees, they know, okay, this is what I'm trying to prove. This is the proof I'm going to send to the network. and they just need to verify that proof. We don't need to sequence anything. We don't need any centralized layer that reorders the transactions to bring back determinism or to tell the user, here's the proof you need to create. Because anytime you have something like that, if you imagine there's some element, right? We're just going to describe it vaguely, where a user is trying to build a transaction and some element says, okay, here's the transaction, here's the proof you need to make for that transaction. That has to be centralized, because how do we trust that what it's telling me is the actual proof I need to create, right?
Okay, so you said that this is something could be run on the user side. Does that mean that I would run it? Would it run in my browser, or would it be the individual dApps that would run something, and then the proof is sent from them to the network, or would it come through like the wallet, the browser wallet, or the mobile wallet I use? What would be the process for it?
So it really depends. For most intents and purposes, it can probably just be on the client side of your browser, right? Behind the scenes in your browser, you'll just produce this proof. Depending on how efficient we want to make these proofs, it might be better to have like the dApps handle it, in which case you send something to the dApp and the dApp will tell you the proof that you need to create. Or even some like backend server that's just general purpose, like ZK Fold has this Maestro is going to run these like super powered high compression proof backends where you can create a more efficient proof that can bundle more transaction information than you would if you just did it in the browser. But for like 90% of cases, it should be fine to explain this in concrete terms, right? Say you can do 20 swaps by just doing the browser, right? Maybe you can do 30, 35 swaps if, Maestro or some backend handles it.
Okay. So does that bring any centralization into it then, or is it still, can they impact what's going on in them proofs or in them transactions? Generally, these will be swaps or
So
some type
the
of
nice
DeFi.
Yeah, the nice thing is they can't impact what's going on in them. And the reason for that is because they're not operating at the protocol level. In the ZK EVM solutions, they're reordering the transactions that happen at the protocol. So they have to say, okay, this is the sequence of transactions, and they're describing it on the actual L2, right? In these cases, these proof backends can't impact the order of transactions on the Cardano L1. They're not even built into the network at all. So all they could do is submit you a proof that's incorrect, right? And they could say, okay, go and submit this to the network. And then when you submit it, the proof will just be rejected because the network, the smart contract that tries to verify it will say, yeah, this is incorrect. So they couldn't like reorder your swaps or do anything malicious. They could just send you a fake proof, right? In which case, when you try to submit it, it will fail.
Okay. So is this something that could get rid of batchers on dexes at some point? In that if swaps were handled like this, you wouldn't need batchers matching the swaps? Or is there anything there?
Yes, so there's a few different types of scaling. So this isn't a roll-up solution. This is a individual transaction-based scaling solution. So what this would do is say right now batchers can process an upper limit of like 40, 45 orders in a batch, right? At the Plutus V2 level, right? Once all these new Plutus V2 ops come out, it'll be about 45 orders per batch at max. With ZK scaling with Plutus V3, you could imagine that number gets to 150 orders, 250 orders. But it wouldn't actually solve the batching problem. That would be the next ZK scaling solution, which is ZK rollups. And ZK rollups, instead of scaling one transaction and just bumping up the limit of computation that you can do and the number of orders that you can fit in one transaction, it will actually bundle tons of transactions together at the L1 level.
Okay. And so I don't know if we referenced or not. A lot of this, the primitives that are needed for this are coming in the Chang Hardfork, which I don't think we have a date on yet, but towards the end of Q2, maybe into Q3. With the next phase of this bundling transactions, would the basics of what's needed for that be included in this hard fork, or would there be more work needed at the layer one level?
So it depends on what type of bundling transactions we're looking at. If we're looking at allowing someone to build a ZK-based rollup solution on Cardano as an L2, right?
Mm-hmm.
Then that would be included. So once that comes out, people will be able to build scaling like layer twos on Cardano that rely on ZK rollup solutions. And this is actually pretty incredibly impactful, because if you look at Ethereum, right, since the last bull run, what happened at what were sort of the major catalysts for innovation and price impact on Ethereum? And it was really layer twos. It wasn't, a lot of people think that Ethereum managed to scale better than we did, or have more impactful changes over the past 3 years, but that isn't really the case. They spent a lot of time basically implementing proof of stake, and that was it. But the 90% of the innovation was with the L2s. So on Ethereum, when someone wants to go do fast transactions at low costs, they just on-ramp onto one of the layer 2 scaling solutions like Polygon, or any of the others. On Cardano, when someone wants to do that, they have to leave Cardano and go to Solana or Ethereum layer 2s, which is a problem. So it's a problem that's addressed, like you pointed out, by this Plutus v3, in that now we can easily build these layer 2 scaling solutions directly on Cardano. So instead of leaving Cardano to go perform these transactions, they just on-ramp to a layer 2 on Cardano, perform those transactions, and then off-ramp back onto the layer 1.
Okay, yeah, I think obviously there's a lot of potential in that, because not everything needs to run on the layer one, and lots of things need to run faster than what the current Cardano layer one can run at. Hopefully in time we will have faster finality and everything on the Cardano layer one too. But even if we do have that, we still don't want everything running on the layer one, because you get to the stage where the chain starts to get bigger and bigger, and then you have storage capacity to worry about for block producers, and you want to keep that minimized in time too. There's one thing then, so just on the proof of, so if you submit the ZK proof to the chain, even for an individual transaction, how is that verified by the chain then to make sure that it is actually, is that down to the deterministic, the way that Cardano transactions are deterministic, or how does that work? Is there room for people to bluff the transactions, or how does that work?
So there's no room for bluffs. These proofs are probabilistic, but they're probabilistic in the same sense that a pub key hash is probabilistic, in that in the world of theory, it's theoretically possible for me to fake a signature from your private key, through hash collisions and whatnot. But in practice, this doesn't happen because the chance is just infinitesimally small. And it's the same with these proofs. In practice, you'll never see anyone be able to create a fraudulent proof that would be accepted by the network. It's possible because so how this works is these primitives introduced will allow us to write smart contracts that, instead of actually performing computation, they just verify proofs, right? That's all these smart contracts do. So when someone submits this proof, the smart contract will just check that the proof is correct. And if the proof is correct, the transaction will succeed. And if the proof is incorrect, the smart contract will reject it and the transaction will fail. And yeah, exactly as you said before, there are things that we want to be done on layer 2s, but that's not to say we're not directly scaling the L1. So this is scaling the L1. It's scaling the L1, especially in terms of the dApps throughput capacity. So the number of transactions and orders that dApps will be able to handle on Cardano will vastly increase, right? And this will solve a huge bottleneck, which has been, the throughput limitations of individual dApps on Cardano. A lot of the time, the network is full, but the network is full because dApps have been sort of forced to submit many transactions in a block with a small number of orders. With this scaling solution that is enabled by Plutus v3, you can imagine dApps throughput increasing, 100-fold, in which case dApps would be able to submit hundreds of transactions in a block.
Yeah, I think I keep an eye on the chain congestion just to see what it's at. And anytime it goes near 80, 90%, I go looking to see there's some launch happening, whether it's an NFT launch or whether it's meme coin or some token launching. Generally, it only takes one really big event right now to congest the chain. So if you can solve something like that, then I think that's a massive step forward. And for current apps that are out there, either dexes or lending and borrowing or something else, how could they implement something like this? Is it a complete rewrite for them, or is there anything they can do to adapt what they have now?
Yeah, so unfortunately, at the current status of the scaling solutions, it'd be pretty much a complete rewrite. Um, Very soon, I mean, we're working on building a language that, you know, sort of translates one to one so that they don't need to do a full rewrite, and existing code can just be compiled into ZK circuits. But this is a very hard process and requires a lot of a lot of work and a lot of auditing to make sure that the resulting code is safe and correct. So yes, as it stands now, they would need to do a full rewrite. But the development cycles in Cardano have gotten much, much faster. A lot of people complain about how long it took for Plutus V1 apps to come to Plutus V2, but this is a product of a few things. One, social migration is very difficult. It's hard to get people who are using the app to react to things. So even if the V2 code and stuff is ready, if you just release it, but all the liquidity and stuff is locked in V1 contracts, then it's going to be a very bad experience for people trading in these sort of fragmented pools. So the first step is you need to talk to all of the big liquidity providers and get them to migrate. The second big problem has been that um, development on Cardano was very, very difficult. There were maybe less than a dozen developers capable of actually producing mainnet application code on Cardano for a very long time. And now that's sort of completely transformed. Now you can have someone come into the Cardano development ecosystem, and within a week they can put their own application on mainnet. Something like that wouldn't have been possible even 6 months ago. And this is now because of things like Aiken and increased developer documentation and way better wallet support and way better off-chain frameworks. That's not to say there are some things that are still lacking, but all in all, like the experience of actually bringing code to mainnet has completely transformed over the past 6 months. So I get that it does sound sort of disappointing to wait for the full rewrite, but what would have taken, the amount of work to get from Plutus v1 to Plutus v2 would be nothing like, it would be way quicker to actually migrate a v2 app to a ZK app. So you could expect much quicker timelines on that.
Okay. Yeah, and I suppose look, it opens the doors for other developers, like you say, they can come in now and they can bootstrap so quickly to get something up and running. So it does open the door there for new developers to come in and build and try and compete. And if we do get to like the what's happening on Cardano, the trading volumes and stuff like that right now are very low. But when they start to go up, then there's going to be a bigger demand for dApps that can process more transactions and faster. So it will open up opportunities there and put pressure on current apps to really upgrade what they have themselves. So what do you see as the scaling roadmap for Cardano? So we have this hopefully coming, well, not hopefully, it is coming in Plutus V3. Input endorsers is another one we hear a lot of talk about. From what I gauge, we're still at least a year, 2 years away from having that on mainnet. It's one I'd love to have now, obviously, for what it can do and throughput and speed. But what's your view on the scaling roadmap?
So a great thing about our ecosystem is that we've been very flexible depending on what is illustrated success, right? So when we first started, we spent a lot of time on things like the PAB, And then when practical solutions came out, like Lucid or other off-chain frameworks, we pivoted as an ecosystem. And we pivoted because they've demonstrated some level of success and adoption, right? And what we expect to happen here with this Plutus V3 thing is we expect it to also similarly demonstrate scaling improvements, huge scaling improvements. And we expect this to sort of guide the roadmap. So a lot of people are very focused on input endorsers, and it's something that I'm excited about as well. But it requires much larger structural changes to the network than ZK scaling would. So my hope here is that Plutus V3 comes out, right? We see this huge throughput increase in dApps that adopt it, that adopt ZK scaling approaches. And then that makes people start to think, if at the dApp level, right, we're seeing this huge impact on scaling, why don't we try to bring this scaling to the L1, right? And that was the sort of L1 rollup that I'm talking about. And as I said, like, this can be extended to L2s, right? So for instance, the second Plutus V3 comes out, someone can make this zero knowledge rollup L2, right? And if people interact with that and they say, wow, my transactions are so cheap and the throughput of this network is so insanely high, why don't we just bring this onto the L1, right? That, I think, is a hugely valuable scaling approach. And I think that the timeline for something like that would be much quicker than input endorsers. So my goal and my hopes here are that Cardano can start looking more seriously into ZK scaling on the L1 instead of just on a transaction level, on a roll-up level. So we could actually roll up many Cardano transactions into a single transaction natively on the L1 without smart contracts and without any L2. And this would be a really, really competitive scaling solution that other networks can't replicate. This is a hugely strong property of Cardano, transaction determinism. And people don't realize the amount of sacrifices that we as a network have had to make to actually achieve that. But now that we have it, it's something that can't be replicated, basically at any level at all by other networks. If you tried to, proof of stake was something that it took Ethereum a very, very long time to switch over to, right? Mm-hmm. But if Ethereum all of a sudden said, we want to make our transactions deterministic, this would almost be impossible, right? It would almost require an entire rewrite of the Ethereum network, which is why it makes sense to me that we should focus on these types of unique strengths of Cardano and focus on more strongly on ZK scaling than input endorsers, at least first and foremost. One, because it's a lower hanging fruit, and two, because it's almost impossible to replicate. Even other UTXO blockchains like Bitcoin or Ergo wouldn't be able to do this, or Radix.
Okay, that's good to hear. And on the layer 2 side of things, for if they go full roll-ups, there is the structure we have with Cardano right now for roughly every 20 seconds a block. Is that still okay with that and current block sizes, or do we need any changes there?
No, yeah, that's a great thing about this. So input endorsers is a much larger change because it involves actually changing, settlement times on the network and finality. For instance, it'll make the block times quicker. But this change, we could leave the 20-second block time, but in practice, what you would see is the amount of information the amount of transactions that could fit in the block could skyrocket. Right? If we're looking at potentially, if we exclude smart contract transactions and we just say normal transactions and we want to roll them up, you could look at, 1,000x, 2,000x throughput increases by just, instead of including the transactions themselves, you include proofs of the transactions.
Okay. Yeah, for people who really like TPS, that sounds very good to be able to get to them type of numbers. And look, where we want Cardano to go, we need them types of numbers for the types of areas we want the chain to expand to in time. Then we do need that, and we will need some of them on the layer 2s like we talked about. Is there anything else that we should have covered here, or anything else you're looking at in the area that would be good to put out there?
Yeah, really quickly, I want to bring back to what I said about how Ethereum scaled. And a lot of Ethereum's success has been due to the community of Ethereum, right? If you look at the big cataclysms of, price improvement and the success of Ethereum, it wasn't that they switched from proof of work to proof of stake. In fact, that switch has been really painful, and there's been a lot of obvious glaring issues with it, with Lido and other concentrated issues. It was sort of that large stakeholders of Ethereum, or even just small development firms, decided, there's something wrong with the layer one, and I want to build something to address it, right? And this is where Polygon came out, or many of the other layer two scaling solutions, or the ZK EVMs, or a lot of the token standards and things like that. It was just individual projects that said, here's an issue, I'm going to go fix it, I'm going to build an L2, or I'm going to build this extension layer. And that's something we haven't really seen on Cardano. We see a lot of projects say, okay, here's an issue, but IOG, go fix it for me, or Cardano Foundation, go fix it for me. I think that for the future of our ecosystem, it is really, really important that we start taking these things into our own hands, right? If you have an application and you say, okay, the current throughput is not satisfactory for my application, then build an L2, right? Or look into collaborating on these L2 scaling solutions. In practice, it sounds like a daunting task, but it's not really. If you look at how a lot of the L2s on Ethereum started, they're really just like centralized multi-sigs, right? That have slowly scaled over time and built more infrastructure over time. And it sounds sort of unappealing that, oh, it's just an insecure multi-sig, but in practice, that's almost what every single layer two boils down to, these multi-sigs at the start, right? And they have some roadmap to slowly decentralize these things. But there is always a cost to high throughput. You can never get this for free. And it's important that people who want to engage in this sort of high transaction, high throughput environment, a lot of the time they're okay with accepting that centralization and saying, okay, fine, it's a multi-sig. Like people use Blast, right? They use Polygon, they don't care, right? So they need an avenue to do that on Cardano. So I encourage people listening to sort of look at things in that light and maybe, look into more centralized scaling solutions as L2s or sublayers, because we don't really need, like for NFT PFP launches, right? We don't really need them cluttering the main chain, which is supposed to be used for like serious financial transactions.
Yeah, that's a good point to think for people to take away as well, is that not everything needs full decentralization for whatever they're running on certain days. And you can go in and out. It's like with centralized exchanges. I tell people go in, use, but get back out again. And you can do that with layer twos, like that for launches and things. If it's a trusted layer two, you can go in and use that for launches. Maybe there is one set up for like that, NFT launches or token launches or whatever it is, individual use cases. Final one I'm going to put towards you is, we touched on a bit on finality and speed of transactions. Is there any short-term wins for Cardano there, or are we more looking at the big overhaul that input endorsers would bring?
No, actually, so there are there's really big wins that we can make relatively quickly. And this is why at the beginning I said it's so important. A lot of people faded the fact that we were working on governance for so long, but it actually brings us a hugely valuable asset in terms of the rate at which we can iterate and change on these things. So as soon as the governance SIP, right, is pushed and we have access to protocol parameters, right, the first thing I expect to see is people making proposals to say, let's bump protocol parameters a ton and let's reduce block time, right? And in practice, what we'll see is if people really value scaling enough to increase hardware requirements of nodes, then that's what will happen. And even right now, right, the hardware requirements of nodes won't even be impacted very much at all if we bump protocol parameters, like increase or even reduce block time significantly. So yeah, I expect that the second that functionality reaches mainnet, the first like 20 proposals we'll see are, let's reduce block time, let's bump protocol parameters, let's increase throughput by just bumping numbers up.
Yeah, that is one that I would like to see reduced if it's possible. I put it to Charles when I had him on there a month or two ago. He said it's set for a reason, I think as we're going forward, P2P and the way things are going, block propagation now is a lot faster than it was. So hopefully we can bring that down, because even that on its own means you're getting more blocks per minute. If you could bring it down to 15 seconds, you get one extra block per minute. That means you get all them extra transactions in there in that minute as well. So all these small things can help improve.
Right. And I'm not trying to say that they were set incorrectly. So they were set like this to be conservative, which makes sense when we've sort of built our whole network image on, the fact that we've been very slow to change, and we research these changes heavily. But a good thing about this decentralization of the control of protocol parameters is that if the ecosystem is more willing to accept risk, then we can iterate much quickly, right? So IOG has been very conservative in protocol parameter changes, but the ecosystem might say, we're okay with a little experimentation or a little faster iteration on this. And because the cycle of these things has been handed over, the torch has been handed over to the community. If we really want scaling, then we can do whatever we want with the proposals. So
Yeah.
it puts it into our hands. Yeah, but there is like, for instance, if all of a sudden we make a proposal to like bump, protocol parameters by like 500%, and we're a little too vigorous in this, then yeah, it can backfire very quickly.
Yeah.
But they've been very, very conservative. So I expect there's going to be a happy middle ground that we can come to without making too many sacrifices.
Yeah, I think so. I'm not talking about 1 second blocks or anything. It would be nice, but I don't think we ever get there. That's what you have other. That's what you have layer twos, and you have different things for. I won't say we'll never get there. Maybe at some point, but I don't see it in the near future. And a lot of the parameters would have been set initially, so that could be 2-3 years ago they were set. There's a lot of improvements on the network. We talked there about how it's improved for developers and how fast they can start to build now compared to initially. So there's lots of improvements all the time. Phil, thanks very much for your time. I really do appreciate it. I learned a lot here. I hope others watching this learned. Please do share it out. Let people know what type of scaling is possible on Cardano, and even a few things I'm sure people will have picked up lots of bits. I will leave links to all your socials down below for people who want to follow you on Twitter, as well as Anastasia Labs. Maybe there might be projects looking for developers. Actually, is there anywhere developers should go? Anyone looking to build on Cardano? Is there anywhere you recommend they get involved to start out? Yeah, you're just still on mute there. Sorry.
Yeah. If you want to start learning development on Cardano, I would jump into the Aiken repositories or jump into our Discord. And if you're a project that wants to even get a technical consultation or a scaling consultation, then feel free to reach out to Anastasia Labs. The development experience, in fact, soon they're launching an Aiken. We used to have the Plutus Pioneers program, but they're launching this Aiken Pioneers program, which I think is going to be pretty revolutionary and very helpful in terms of onboarding with a more comprehensive. So the original, lesson material used to be very theoretical, but this is going to be more like, okay, from zero to hero, here's how you build an app on Cardano. And I think that's probably a great place to start as well. Also, the TX Pipe Discord, if you have any questions about Aiken or anything related to Cardano development.
Yeah, I think they go in there live coding lots of days as well for people to just jump on and see what's going on. So it is good. And I think important things is to spread it out there that you don't need to know Haskell anymore to build on Cardano. There's a lot of ways to get involved and build up your dApps without having to have that type of knowledge, which is a great thing for the ecosystem.
Yeah, I always say, we had this like influx of these scam tokens recently, if you've seen, where like they send you tokens and it's like, oh, go redeem your thing. In a lot of ways, it's a bad thing, but it's also an extremely bullish sign for the ecosystem. Because if it's easy enough for these scammers, which are like most of the time like teens that are just copy pasting lines of code to build these things, then the developer experience, a year ago that wouldn't have been possible. The amount of time it would have taken a scammer to learn how to develop something like that would have been so immensely hard that it just wouldn't have been worth it. So in a lot of ways, this is a demonstration of, oh, wow, it's not that hard to get started developing on Cardano now.
Yeah, and I know you're a big proponent of open source, and as we get more and more projects and contracts open source, that will make it easier, not for scammers, but for real developers to come in and build fairly quickly to bootstrap their initial prototype. So thanks very much again. Do appreciate your time, your knowledge. Everyone watching, do share it out. Subscribe if you're new. Comment questions or anything down below. Maybe we could do a part 2 if you have time at some point to go through some of the feedback that's there. Appreciate everyone watching, and I'll talk to you soon. Thanks.